Okay, in this video, I'm going to show you guys how to use the diagonal rule chart and the colored periodic table to kind of help you with noble gas configurations if you're not entirely comfortable with the colored periodic table. So the element that we are going to start off with is we're going to start off with element AT. That's what we're going to do the noble gas configuration. So the first thing that you absolutely have to look at is just any periodic table. It doesn't have to be the colored one, but that's the one that I have on hand, so we're going to use this one. So when we find AT, it's all the way down here in the lower right-hand corner. We will go up a row, and then all the way over to our noble gas family, which is this last column all the way on the end. So we're going to start with xenon. That's the first thing that we're going to write in brackets. So we'll do XE. So what you will need to use for this to figure out where to start is looking on our chart, xenon, the very last thing you would write, its highest energy, would be the 5p6. Since it's in this fifth row and it is in the p6 column, that's where, so 5p6. That would be the last one for it. So when we go back to our diagonal rule chart, if we look at 5p6, our next one is the S block. So we would write in 6s. To figure out how many electrons we will need, there's two different ways of doing this. You can either look at the atomic number of AT, which is 85, and ZE, which is 53, and you can subtract them, or you can physically count how many elements are in between these two. So if we physically count them, if we start with XE, we'll go here. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 31 elements in between xenon and AT. So we need to place 31 electrons out here. So going back to our little charts. In the 6s orbital, it can only hold 2, so we've used 2. So we've reached the end of this one. So if we jump up to our next one, we'll start with 4f. So we start with our 4f, and that one holds 14. So far we've only used 16 electrons, so we still need to continue on. Then after 4f goes the 5d, 10. So far we've used 26 electrons, so we're still not there. We've got to use 31 of them. So now we go to our 6p. So now we don't have enough to fill this. We only have 5 electrons left, so this is going to be the 5p5. We don't have to fill it completely. In fact, we don't have enough electrons to fill it completely.